Hello, I am Boyd Charrington. I am a Senior Training Specialist at Exfo. I would like to introduce you to the Max Tester 730C OTDR IOLM test set. To begin with, there is an on-off button located at the bottom lower right corner of the Max Tester. A single press is sufficient for either operation, on or off. When the unit is turned on, a long press of this button will shut the unit down completely, whereas a short press will put it to sleep or in suspend mode. There is an LED adjacent to the on-off button. This LED's color and state will indicate the tester status. Green flashing indicates charging. Green steady indicates on and charged between 25 to 100%. Yellow indicates a 10 to 24% charge. Red indicates low battery below 10%. Rapid red blinking indicates critically low. Slow red blinking indicates the wrong charger. And no LED indicates a off or suspend. The Max Tester has a tablet-inspired screen, and at the bottom, the center, there is a home button which acts as an Alt-Tab as in Windows and uses a Windows-embedded compact operating system. The various ports and hardware options are described on this slide, and I will let you view their descriptions. The 730C is compatible with Exfo fiber inspection probes, or FIPs, and here are a couple of our newest models along with a few of the inspection tips available. This unit also features a new improved kickstand for ease of use. The serial number is on the rear panel and is important for tracking, inventory, and maintenance purposes. The first app I would like to talk about is Connector Max 2. I'm discussing it first because the first test you should always conduct is the scoping and cleaning, if necessary, of the unit's optical port. If it isn't dirty, don't clean it. And of course, if it is dirty, it must be cleaned. This is the first connector which the OTDR transmits out of and can greatly affect your results. The tips used to clean this and scope the port differ according to which EUI you use, whether it be SC or FC. Regardless of the connector type, the ferrule is always APC, and an APC scope tip is required. There are two ways to view the connector. One method is to use a port adapter, which when attached to the FIP, you can insert into the EUI and view the cleanliness of the port. The other method is to remove the EUI by twisting it counterclockwise 1/4 turn and pulling up. You can then use the 2.5 millimeter angle polish connector tip to view the connector's cleanliness, just as you would on an APC jumper. If the second method is used, you must be very careful not to damage the meter's connector when replacing the unit. To replace it, align the little tabs on the bottom of the EUI and twist clockwise 1/4 turn until it seats. I am now going to click on the Connector Max 2 icon to open the program. What you see is an example of Connector Max 2 screen and its capabilities when a connector is scoped. Notice that the four available options are: 1. Auto centering, the cladding and of course the core automatically positioned in the center of the screen. 2. Auto focus, the tool will automatically adjust and focus on the fiber end face. 3. Auto capture, when the centering and focus have completed, Connector Max 2 will take a picture of the end face. And lastly, 4. Auto analysis. Connector Max 2 will conduct an analysis of the condition of the connector. When the analysis is complete, a pass or fail result will be provided at the top of the screen. You can also enable or disable any of the four functions by selecting or deselecting them independently. As with other Exfo thresholds, green is good, red is bad. Notice I must also select the test configuration as to what type of connector you are analyzing. In this example, you see IEC SMSF APC, which is single mode, single fiber, angle polish connector. This option will always be the selection when testing the port on the meter itself. To select the type of connector with the stylus or mouse, if you have one attached, on the right side of the screen, select FIP, then select the type of connector you wish to test. At the top of the window, it automatically has selected Apply to Next Capture. Notice there is also an option for Revert to Factory Settings. As you conduct these critical Connector Max 2 tests prior to using the OTDR or IOLM, notice that on the FIP itself there is a camera button. You can control the application from that button. When the scoping is complete, the light on the FIP will either turn red if the test fails or green if the test passes. There is no need to use the stylus to start and stop the test. This is a quick description of Connector Max 2, and more detailed training is available. I am now going to conduct a test of the connector on my Max tester as previously described. As you can see, the connector is dirty and the test fails. So I will clean the connector using a one-click pen. I will now run the test again, and you will see that it now passes. It is not always so easy to clean, but if you scope and clean, if necessary, at every connector remating, your connector should stay in pristine condition. I will mention here that an APC connector is a little bit more difficult to scope as it requires proper alignment to the scope tip. If you look at the scope tip on an APC, you will see a small line runs parallel to the angled tip and must be in alignment with the keyway of the SC connector. Once this test passes, we will conduct the same test on the fiber connector of the launch bag. Once it passes, we can click the home button at the front center of the Max tester and return to the main screen. We are now ready to conduct an OTDR test. The next app I will talk about is the OTDR. When configured, the OTDR will inject light pulses into the fiber at predetermined frequencies, which are programmed into the OTDR and within the range in which optical communications can take place, generally between 850 nanometers and 1650 nanometers. These frequencies will measure the fiber length and condition by putting to use relay backscattering. It will also display events along the fiber such as splices, connectors, and other items which will affect its transmission capabilities, such as macrobands. This is a very quick description of an OTDR, and more advanced training is available through Expo. I will now open the OTDR option. Once open, we can see the OTDR screen. This is where the traces will show up and all of the settings which we can use for the OTDR. In this screenshot, you can see that I have selected two wavelengths, 1310 and 1550. I will use the auto function and let the OTDR determine what settings to use of the three options available: range, pulse, and duration. The test is now finishing, and we should soon have a result. The program determined that the fiber was relatively long at just over 50 kilometers. You can see here at the end of the trace. So it set the distance to 80 kilometers. I'll go to the OTDR function to verify that, to enable us to effectively see all the way to the end of the fiber. Going back to the events, I noticed that at 1550, which is the trace in black at the forefront of the screen, at event 2 I have a loss of a .82. It's determining that that is above the thresholds of the meter, what's programmed into it, and so it has come up as red, saying that there's a problem, at least at 1550 at that distance. So it looks like it's approximately 25 kilometers out there. I'm going to shift by clicking the next tab to the 1310. So you can see 1310 has come up in the forefront, and I'll see at event 2 it is also not passing at that event. So some more testing is going to need to be done to find out what's going on out here that would cause the thresholds to be surpassed at event number 2. Going back to the OTDR tab at the top, I see that it set the pulse width at 1 microsecond, which was necessary to be able to see all the way out to the end. That's adjusting the length of the pulse going into the fiber. And the duration is set to 15 seconds, which on this new OTDR, the averaging time was long enough to see a clean trace, so you see they're nice and smooth, without noise which could hide some of the events. Going back to my events tab, I'm looking at event 2, and I see that at 1310 I have a negative 60.5 reflectance. That is of no concern. It's actually a very good connector for a UPC. I'm going to click the next tab again, and we'll see that at 1550 nanometers it's identifying the reflectance at event 2 as a neg 59.5. Pretty good for a UPC. I am now going to cause a macro bend somewhere along the fiber and rerun the test, and let's see how the OTDR is able to identify it. Notice I can save my test and I've started a new one. It's going to run 15 seconds on both of these wavelengths, the 1550 and the 1310. So we will wait for it to finish here. 30 seconds can actually be a long time when you're staring at the screen. Now we can see the result. So notice here at 1550 on my events tab, at the location 2, event number 2 out here, just over 25 kilometers, the loss has changed to a 1.774, which is out of thresholds obviously, and the reflectance is remained pretty much the same at a negative 60.6. So I will go to the next tab. We will shift to the 1310. We see its loss has increased to a 0.923. Its reflectance is at very close, a negative 60.3. The higher the number, the better here as far as reflectance. So a negative 60 is better than a negative 50, which is better than negative 40. So you get the idea here. So what we have done here, because the 1550 is a longer wavelength and it has more loss at event 2, we can see that somewhere out there at event 2 we have created a macro bend. So some type of a tight bend in the fiber that the longer wavelength is having a harder time negotiating than the shorter wavelength. These macro bends occur where people touch fibers, as I just did. So in splice cases, in fiber panels, for the most part where people touch them, they can be created by an auger or some type of a damage out at a certain location. But in this case, it's right close to that connector we had at event 2. So I've gone out here to where my macro bend was occurring, and I've fixed that macro bend, and so now I want to rerun my test. The test is completed. I'm going to go back and I'm going to look at my 2 frequencies that I've tested with, see what's happened. At event 2 I can see at 1550 my loss is back to a 0.82, negative reflectance about 59, so you can see that it looks like maybe the macro bend's gone. Let's look at 1310. If I look at 1310 I can see I have a 0.86 loss and a reflectance of a negative 60. By changing my settings here, changing my range, my pulse width, my duration, or adjusting these parameters, I might be able to see what's going on out here at 2, but 25 kilometers is quite a ways out there. So that is maybe something for the more advanced OTDR class. I'd like to shift gears here just a little bit, and I've connected a new launch bag. It's a 500 meter launch bag, and it is using LC connectors at the end of the launch bag away from the test unit, and it's connected in test box, which I know has some short fiber with some built-in defects. So we're going to go ahead and do a test here. I'm going to start the test. We can see that my auto function has set it to a 1.25 kilometers at a 10 nanosecond pulse. That's 10 billionths of a second, and it's going to average over 15 seconds at each wavelength. So already on the 1310 here I can see there's more events in here. Shifting now to 1550, and I can see at 1550 something's changing as I watch and analyze this. And it is finished. So I want to go back to 1310, click the next button. I can come back and go through each of the events. Notice the bottom of the screen synchronizes with the top of the screen as I shift through these. I can see that everything looks good until I get down here to I'm not concerned about the loss across the span itself. I know it's a very short fiber and the thresholds are determined and there's some loss there, but I'm not concerned with them. At event 3 it looks good at a .09 on my loss, 53 on my reflectance. And I know event 4 is the end of my fiber. I placed a receive jumper out here at the end so that I could determine the cleanliness and the condition of the connector at event 4, a .12 on its loss, and a negative 56 on reflectance. It's passing. When I look out to event 5, which is determining the very end, that is the end of my receive fiber, it's seeing a negative 19.7 on my reflectance. That's to be expected. It's looking into the back of an unterminated LC connector. I'm going to shift over to my 1550, and as I go down through right away, I can see that event 3, I have a loss of 1.274, which is high. The reflectance is good for an LC connection, but my loss is too much. So I can see that at event 3, my 1550 frequency has more loss than my 1310, so right away I know I have a macro bend. Event 4 again is the very final connection on it, and everything looks good there. It passes its tolerances. The next app I would like to talk about is IOLM. I'll click on the IOLM app. You can see it opens up to the IOLM screen or IOLM tab, and I've input here previously the launch and receive fiber. I'm using launch and receive fibers. That will help me identify the beginning connector, the starting connector on my fiber under test, and the final connector on my fiber under test. Without these launch fibers here, you really don't get a good measurement as to the loss on those. Another option you have here, if you don't know the length of your launch fiber, is to click on measure. So you'd check the launch fiber or receive fiber box, and then it will measure it for you. You'll see as it does this test, this might not be exact. The launch bags are labeled 150 meters, but you'll see that that's not an exact. It's close. My fiber under test on this test box I'm using is rather short, and you can use different size launch fibers. There is recommended tables to say if you're testing a long fiber, use such and such a length, or if you're testing short fibers, use a shorter length. It really isn't that critical because it's going to separate as you'll see, the launch fiber from the fiber under test. So with that, I'm going to go ahead and start my test. And you'll see that this takes a little while to run. It doesn't go extremely fast, but what it's doing is running multiple pulse widths and multiple frequencies. As you can see right now, it's running the 1550 nanometers, but it's going to run multiple frequencies and multiple pulse widths in order to identify all of the items out here on my fiber under test. And as you can see, I've already got quite a bit of information, but this can take about a minute to run sometimes. It kind of depends on how long your fiber is. You'll notice it's already identifying the A end of the span. Notice that that's at the 0 point, so it's determined that even though I put in 150, the launch fiber is actually 152.9 thus far. And as you can see down at the end, I put in 150 and it's saying it's 152.9. But let's let it finish and see how it ends up. It's now running 1310. Should be getting close to finishing because this is a relatively short test box. So you can see now it's completed its test. At the A end, at 0, the 0 mark, so this is the beginning of my fiber under test, it's green. So the tolerances, thresholds that are plugged into this meter, they're editable, but I just left them at default. Green's good, red's bad. So my first connector, it's saying that's a good connector. And if I click on this connector, it's telling me my reflectance is a -54, and you can see my loss at 1310, my loss at 1550. So it's actually a very clean connector. I've cleaned and scoped these prior to our test. If I click on the next one, that's 49.9 meters out. You can see I've got good loss on my 1310, my 1550, and good reflectance. These are LC connectors. But when I get out here to 99 meters, I got a problem. I got something wrong, and it does give me a narrative down here. It tells me the connector or bulkhead is damaged, dirty, not well connected, inspect and clean as needed. If I click on the next one here, it's telling me that to inspect the fiber in this area, search for excessive bending or cable compression. So it really, you can't go wrong. It's identifying through this icon a micro bend. And then when I look at my end connector out here at 149.6 meters, the B end, so there's a little scale up here to show you exactly what you're looking at. It's saying that that connector has a problem, and notice it's got a high loss at 1550. So 0.07 looks good at 1310, but if you were to run 1550 on this, it's got some high loss there. Can be hidden a bit by what you're seeing here with this macro bend. You need to go fix the macro bend, and then that's going to give you a better view to this connector. Possibly go fix that connector also. If your fiber has some length to it, which this does with a launch and receive bag, you get a little blue arrow here showing the end, and so this is the end that's just hanging out here in the breeze, but it's enabling me to see this last connector on my fiber under test. File Manager and Data Mover I will explain together. File Manager is a location where all saved files are stored, and Data Mover is an app which allows you to move those files to a USB for transfer to a computer for further processing, for example in Fast Reporter 2. Our next app is the Power Meter VFL app. Your unit can be equipped with an optical power meter to measure absolute power in dBm or watts, or insertion loss in dB. The power meter can detect modulated signals at 1 kHz, 2 kHz, 270 Hz, and 330 Hz. The built-in power meter can also include a visual fault locator or VFL to inspect and identify fibers. I suggest that as you use this app or any other of the apps, you use the onboard user guide, which is accessible by selecting the question mark at the bottom right of the screen in each app. Simply put, the power meter measures the power on the fiber, and the visual fault locator or VFL transmits a red light on the fiber for tracing and identifying faults. This tool is easy to use, and I think you'll find it very useful. And as you can see, you can even make it blink. Finishing up now with the few remaining items on the Max Tester 730C, you can see the configuration app. This is where the settings for the unit are located. The documentation app contains the user guides for a detailed explanation of everything available on the test unit and the use of it. Internet Explorer you should all be familiar with, and notice that by default, when connected to the Internet Explorer takes you to exfo.com/mymaxtester for more information, and you can request web-based training here, technical support, so forth. VNC is for virtual network connection. It enables you to connect the Max Tester to your computer, even remotely, which is the method I have been using to control the unit to create this training. And lastly, but certainly not least, is the Exfo Connect client. This program, if purchased, allows the unit to either manually or automatically connect to Exfo servers for upgrading of software, inventory management, file transfer, and many other functions. We thank you for viewing the training on the Max Tester 730C. If you wish to get additional skills to correctly assess the performance of fiber optic networks, please contact us to attend our certified Exfo fiber optic training. Our email address is techtraining@exfo.com.